Howdy guys, today we'll be going over more integral basics and the power rule. So let's get started. Just as a quick refresher, um, an integral is basically the opposite of the derivative. We're given the derivative and we want to get back to like the original function. So in this case, we have this 2x and we're like, what was originally before it was 2x? So kind of knowing and like using our instincts, we know that the derivative of x squared is going to be 2x, right? So that's going to be our answer here. The original function of the derivative of 2x is going to be x squared. Now, you may be wondering where this funny little plus c is coming from, and it's because there's actually several ways that we can get the derivative 2x, right? So we see one way is just the derivative of x squared, that'll give us 2x. But what about if we have the derivative of plus 7? No? Well, the constant 7 just drops, right? So that'll also give us 2x. Or what if it's x squared plus 17? 27. A million, right? There's just so many possibilities for here, right? But what is true is that there could be a constant, right? So just because the derivative of 2 is 2x, we know that the original function is x squared, but we don't know if it has another constant added to it. So that's why the plus c is there. It's just to keep track of this possible sneaky number that could be in here. Okay. This is a really easy way to both lose and get points. In the AP exam, you'll just get points by just adding that plus c. So worst comes to worst, just add plus c and maybe you'll get a point here or there. So let's go over some rules. So first of all, the integral of 0 is just going to be a constant. Okay, that makes sense, you know? Now, if we take the derivative of any constant, such as 5 here, that's just going to give us 0, right? The derivative of 7, 12, 13, that's all going to be 0. Okay, what about addition and multiplication? What about if we're just adding or multiplying constants? Well, let's take this first example of multiplication. So in multiplication, and we're integrating, we can just very simply just take out the multiple, right? So in this case, x is here, k is in there, which is just a number, and we can just take it out. No strings attached. So kind of when we're looking at integration, we want to be like remembering the relationship between integration, and derivatives. So let's look at this counter and how this looks like in derivatives, right? So if we want to derive 5x squared, right? Maybe you don't do it explicitly now, maybe you're just doing it in your head. But what's actually happening in the background is you're taking out this 5 from the derivatives, right? So you can just take out this 5 and then just take the derivative of x squared. What's the derivative of x squared? 2x. So we can just multiply 5 times 2x and that gets us 10x. So notice how like the 5 was just along for the ride? The exact same thing happens with the integrals. Okay, what if it's like a plus or minus situation? What if we're adding and subtracting? Well, in this case, like right here, we're adding f of x to g of x. Well, we can just, again, just treat the two independently, right? So we can just integrate first f of x, and then we can integrate g of x. And again, we see this in derivations, sorry, in this case. So let's take 5x squared plus 4x, right? Well, this is the same thing as first deriving 5x squared and then deriving 4x. And again, maybe you're doing it all in your head really quick now, but that's what's happening in the background when you really break it down. So the derivative of 5x squared, that's going to give us 10x. And the derivative of 4x is just going to be 4, so we just combine that all to get us 10x and 4. And the same thing happens when you integrate. Okay, this final one is like a super important rule, and you need to memorize this. Like, you need to. There's no getting around it. And this is the really fancy, like, mathematical way of writing it down. But if you're more of a numbers person like me, um, I'll walk you through what this means in plain English. So all this is saying is that when you see a situation where it's like x to the power of something, where x has an exponent by itself, such as x cubed, you're going to look at the exponent, and then you're going to add 1 to the exponent, divide by the new exponent. So in this case, we have the exponent 3, right? And we're going to add 1 to the exponent, so that's going to be 3 plus 1, and divide by the new exponent. So again, 3 plus 1. And then we have to add c to that. Again, don't forget the c, right? So that's going to give us, in the end, x to the 4th over 4 plus c. And if you don't believe me, let's test it out, right? Let's see if we can go backwards again. Let's check ourselves. So 1/4 x to the 4th plus c, right? So again, when taking derivation, we're gonna bring down this 4, this exponent down, and multiply it. We're gonna have 4 over 4. And then we have to subtract 1 from this exponent, right? So that's 4 minus 1, which is 3. And then what happens to the constant? The constant just becomes plus 0. So in this case, we have x cubed. So this power rule is just the backwards way of doing the derivation of a number with an exponent. There is a little caveat where like the exponent cannot be -1. If the exponent is -1, there's a special case for that, which we'll go over in future lessons. So let's go through some examples, right? Here are kind of all our rules combined. And let's go through some examples. So let's take x to the 7. So already what I'm seeing is that this is x to the power of something. So I immediately think power. X to the power, right? So all we're going to do is we're going to take x, right? And then add 1 to the exponent, divide by the new exponent. So add 1 to the exponent, 7 plus 1 is 8. And then we're going to divide by the new exponent. And that's our answer, with the plus c, right? Okay, let's take on the second one, right? So now we're seeing again the situation where it's like x to the something, x to the power. But now we have a 5, which it doesn't matter, right? We're not going to get caught up in it because we realize that we can just use this rule right here. We can just take out the 5 and ignore it until the very end. So I'm going to go ahead and do that mathematically. Eventually, you can do this mentally, but for the first few times, it's a good idea to write it out so you know what you're doing. Right? So I just took out the 5 per this rule, right? It's a constant, so we can do that. And now I wonder, okay, what's the integral of x to the 4? Right? We're seeing a power, we're going to use the power rule. So that's going to be 5. It's going to be add 1 to the exponent, divide by the new exponent. So add 1 to the exponent, x to the 5, 4 plus 1 is 5. Divide by the new exponent, that's 5 again. And then we're going to add a plus c to that. And if we just distributed that out, we're just going to get x to the 5, because 5's cancel out, plus c. Now you may be wondering why I didn't multiply 5 and c to get 5c, so why I didn't do this. And this is totally still a valid answer, but because we have no freaking clue what c is, like already, it could be anywhere from like 1 to 17 to a billion thousand, right? it doesn't really make much of a difference to us if it's just 17 or like 17 multiplied by 5. It's still just an unknown number to us, right? So mathematicians do this little like cheating rule where they just get rid of any multiple because it's the same thing. There's like a random number out there. It's not random, but for our sake, it is random. So a random number multiplied by 5 versus a random number is still just a random number. So we're just going to ignore multiplying it out by anything. But I cannot imagine if you put 5C that you would get any points off. Like, this is still a valid answer. But we're just going to do plus C. Okay, let's take this example right here. Now, for the first time, I'm going to like write it all out just so we're all on the same page. But in future lessons, we're going to do this all in our heads, or some of it in our heads. But for now, we're going to realize that there's a plus sign, right? And so we get to follow this above rule, which basically means I can treat them separately. I integrate them separately. So I'm going to write it out for you this time. So that's 2x to the 9 dx plus 3x to the 10 dx, right? And let's first take care. We notice that 2 and x to the 9, again, we're seeing a constant multiplied by something. So I'm going to go ahead and also take out the 2. So I'm going to move the 2 out of the integral to get 2 to the x9 dx. And then move this 3 out of the integral as well to get 3x to the 10 dx. And again, the rule I just employed is this one right there. Okay. Now we've kind of isolated to like the meaty part, the part we care about. And we see in both cases, we have x to the something, which is the power rule. Correct? So I'm going to go ahead and write that out. Right? So we have 2 times power rule. Add 1 to the exponent. So 9 plus 1 is 10. Divide by the new exponent. 10 again. And then plus 3 times. Add 1 to the exponent. So 10 plus 1 is 11. Divide by the new exponent. And then we have to add that plus c, because they're in this polynomial that we got, this right here. In the original answer, before there was a derivative, there could have been a constant. Okay, so we have to add the plus c. Okay, let's do like a final examples. So here's another interesting example. We have 1 over x squared dx. And you may be wondering how to deal with the denominator. And interestingly enough, like we don't really know how to deal with this denominator. It gets a bit confusing. But we can convert this into a rule that we are familiar with. And I'll show you how. Because 1 over x squared is the same thing as 1 to the negative 2 dx, right? And now we see that because the exponent is not 1, we can just use our power rule, right? The exact same way. So power rule, add 1 to the exponent. So negative 2 plus 1 is going to be, that's just negative 1, but I'll write it out for you, over the new exponent, negative 2 plus 1. And then we're going to add that plus c, right? So that's just going to simplify that down to negative 1 over negative 1. So negative 2 plus 1 is negative 1. You see how that right there? And then finally, we notice if we wanted to make this even prettier, we notice that x to negative 1 is just 1 over x, and negative 1 is just adding a negative sign. So this is the result that we get. Negative 1 over x plus c. Okay, this other example is kind of important with t. And I just want to demonstrate that the symbol we care about is the one after the d. So so far we've just been caring about x because it's been dx, and that's usually the default one. But you will see often enough when we use a different symbol. And it doesn't matter what the symbol is. Just look at whatever is after the D, sorry. D as in dog. And then that's the symbol you care about. But it's like still the exact same thing, right? This is just power rule again. It's t to the something, right? So we're going to do add 1 to the exponent. 4 plus 1 is 5. Divide by the new exponent. 5 again. And we add that plus c. Okay, this example here at the bottom, we know from this second rule right here that we can just treat these two things separated by a minus sign as two independent like items to integrate, right? So let's take care first of our 4. Now you may be wondering, okay, like 4, like we don't really have a rule for that. But technically 4 is the same thing as 4x to the 0. Right? Because x to the 0, that's just going to be 1. And 4 times 1 is 4. Right? And again, we can use the power rule on that. So 4x to the 0, the derivative of that is going to be add 1 to the exponent, divide by the new exponent. So 4x, 0 plus 1 is 1. Divide by the new exponent, another 1. It's just 4x. That was like the really fancy way of doing it. Honestly, just memorize that when you see like just a constant like flittering around, such as 4, 5, 23, just add an x or add the variable in. So like if we want to make like a quick rule, that would be like if there's just a number just chilling there, that's just going to be the number times x and then plus c. Right? Okay, so we have this one taken care of. Let's look at the next one, the negative x. And negative x, we can imagine that there's like a little 1 right there as its exponent, right? And again, we can just apply the power rule to that. So x to the first, using the power rule, it's add 1 to the exponent, so 1 plus 1 is 2, and then we divide by the new exponent, 2. And again, we add plus c to that. And yeah, wonderful. This has been integrals for you. I hope you have a wonderful rest of your day.